This video is going to cover the topic of area and perimeter of parallelograms. Be sure the date and topic are at the top of your page. The essential question will be, how do we calculate the area and perimeter of parallelograms? We have worked a little bit with parallelograms. Remember that a parallelogram is a type of quadrilateral, meaning it has four sides, and two sets of those sides are each parallel. In addition to that, the sides are also congruent. That means that the sides that are parallel are also the same length. A parallelogram might look like this. We can see here the top side and the bottom are the same. They have the same tick mark as a code to show that they are the same length. They are also parallel. And these two sides, I'm going to use a different tick mark, are also congruent. They are also an equal length, and they are also parallel. A parallelogram can also look like this. In fact, all rectangles are a specific type of parallelogram, right? So all rectangles are types of parallelograms, but not all parallelograms are rectangles. The first thing we want to look at is how we calculate or measure the perimeter of a parallelogram. And as with any other shape, perimeter is the distance around the outside of the parallelogram. So if I need to find the perimeter of this parallelogram, of course I'll need to know the lengths of all of the sides. I've used variables here, and I've seen that the two A's represent sides that are the same length, and the two B's represent sides that are the same length as well. So to find the perimeter, I can write it as the following. Of course, we'll see these types of formulas written in other ways at times. So perhaps I want to simplify it down to say that it is 2A's plus 2B's. Or I could say it is two groups of the A and the B combined. Right? So these are ways that we would find the perimeter. Most of the time when we see perimeter, if the sides aren't measured for us, we'll need a ruler to find the measurements before we add those up to find the sum. To find the area of a parallelogram, it's a good idea to see how parallelograms relate to rectangles. So we want to point out here that in this parallelogram, I see that if I break this into parts, I have a triangle here on the left-hand side, right? There's a triangle on the left-hand part of my parallelogram. And if I look at that, I notice that it actually would fit quite nicely right over here on the right-hand side of my parallelogram. It would fit right into that spot. Now that I've moved that over, I really see that what I have is a nice, complete, typical rectangle. Right? So a parallelogram could be described as a rectangle that has been rearranged. And because this parallelogram is simply a typical rectangle that's been rearranged, we can actually find the area the same way we find the area of a rectangle. The area can be found by simply multiplying either the length or the width, or the base times the height. So going back to my example up at the top, my base is from here to here. My base is 9 units. And my height, if I go to the top of my parallelogram, just like when I did with the triangle, and I drop my rock till it hits the bottom, I can see that my height is 3. Therefore, my area is 27, and I'm just going to go ahead and call these square units. Unlike a triangle, there's no step at the end where I'm dividing by 2, right? It's just like finding the area of a rectangle, because that's all it really is. It's just been rearranged. Let's use our strategy to find the area of this parallelogram. It's a little bit wobbly, sorry, it's hard with my pen here. But we're going to use the strategy where we look for the rectangle that we can make this into. So I see here that I have a line that I can make that makes a triangle. And actually that would serve as the height of this parallelogram, right? And I also can see that it's sitting here on its base. These are the two things I need. And once again, We're always looking for that base and height to be perpendicular or to make a right angle. If it helps, I can imagine that I moved this triangle over to the right-hand side, and I can see that now it makes a nice clean rectangle, right? That's one way to think about it. Either way, I know that my area needs to be my base times my height, and in my base here is 3 units. That looks like a 5, doesn't it? Let's try that again. 3 units, and my height is, well, my height is 5 units. So I'm going to go ahead and multiply my 3 times 5 to find out that my area is 15 square units. And that's it. That's how we find the area of our parallelograms. For your turn, you're going to take a look at this parallelogram that I sketched out here, and you're going to tell me both the perimeter and the area. So you'll need to decide which values you'll need for perimeter and which of the numbers you'll need for your area. And of course, that was our essential question, how to find the area and perimeter of a parallelogram. So take a try at that. We'll do more practice together in class and come with any questions you might have.